Hello, everyone. Welcome to another complimentary Green Tech Media webinar. Today's webinar is part of a series that the Green Tech Media team, in collaboration with the good folks here at Wood Mackenzie, do throughout the year to help keep professionals in the solar, storage, grid edge, and modernization market, help everybody stay informed through research and analysis on the latest technologies and market trends. Today's presentation, Energy Storage Simple, PC Solutions for Demand Charge and Backup, is brought to you by CPS America. And boy, I'm grateful for anybody who can make energy storage more simple. So I'm looking forward to this one a lot. My name is Dan Finn-Foley. I'm the head of energy storage at Wood Mackenzie. If you're not familiar with Wood Mackenzie, we're a research and analysis shop putting out market research on markets from power markets through solar markets, and I'm the head of the energy storage group there. So very much a vested interest in today's presentation. Before we get started, I'd love to go through the screen that you have in front of you in case you're not familiar with the tool that we use for these webinars. The speaker bios are accessible from the top tabs by clicking on each speaker's name. In addition, you can see the link on the left side of your screen, which will allow you to download a copy of the slides for today's webinar. Everyone always wants to know if the slides are available. The slides are available, so make sure that you download those to have a record of it. Most importantly, I really do want to emphasize this. Please note the Q module on the left of the screen. We'd love your questions used to inform the conversations, make sure that we get the most out of the insights that our experts are going to be sharing on the call today. Really just submit those questions whenever you get a spare moment, and we'll be able to answer as many as we can at the end. Looking forward to it. Today's speakers from CPS America and Energy Toolbase, we have Daniel Hill, Energy Storage Manager with CPS America, Peter Shung, I hope I pronounced that correctly, Director of Product Management with CPS America, and Matthew Simo, the Western Regional Manager for Energy Toolbase. Pefore we dive in, I thought I would just take one moment to set the stage a little bit for what this conversation really means. Energy storage for C&I applications, commercial and industrial, really does need to be made simple. Of the segments that we track within the Wood Mackenzie Wood Mackenzie Energy Storage Service, the non-residential market has actually lost a bit of ground to the front market, and the residential market become one of the segments. We do foresee that changing, and there's a lot happening that is going to change those market outcomes. But really what we're seeing now is that it is going to be a bit of a bumpy ride up to scale for the C&I market. You can see that the coronavirus pandemic affected our 2020 numbers relatively significantly. But from there will be a pretty significant scale up throughout markets. All of this information is available as part of our energy storage subscription service and part of our energy storage monitor if you're interested. Some key notes to highlight is that, number one, the C&I market is really driven by incentives right now, things such as the Massachusetts SMART program or perhaps most dramatically the California Self-Generation Incentive Program. These incentives have pushed these projects towards commercialization, and that's how we're getting sort of the scale up that our guests here with CPS are going to be telling us about. That's allowing these projects to become more efficient, even safer, more cost-effective, and provide more diverse range of services. From there, the services that are being provided are relatively complex, and they do vary. It is one of the more complex markets, especially when you consider demand charge management. It's historically been a major use case for non-residential storage, but in particular, there is more and more of a push to look towards other mechanisms as well to make these projects pencil out. So for instance, grid services is an area I'd really like to keep my eye on. Under FERC 841, these behind-the-meter systems, as we call them, can participate in wholesale markets at varying levels of completeness depending on the ISO, if they're above 100 kilowatts. But beyond that, the recent FERC Order 2222 is going to open the door to potentially aggregating these systems and providing even more grid services. This is already happening within the energy storage market, but within the wholesale market opportunity, this is really where, over the next 5, maybe 10 years, we're going to start seeing applications of demand charge management intermingle with these grid services. And of course, the big word, resilience. It's increasingly becoming a big piece of this non-residential storage conversation, particularly when paired with solar. With the right software, with the right design, energy storage provides a relatively significant benefit to resiliency, to the point where in California, for instance, they're redirecting even more of their SGIP, Self-Generation Incentive Program funding, towards resilience applications. So there's a huge market opportunity, but it may be a bit of a bumpy start to the market. We do foresee it scaling up. And with that, I think I will hand things over to the CPS team, who are going to tell us just exactly how they're taking that conversation and making it simpler. So with that, CPS team, take it away.
Thank you so much, Dan. Hi, guys. Welcome to our webinar. My name is Peter Xiong. I'm in charge of product. Today's topic, we'll talk about energy storage made simple. For those who are not yet familiar of who we are and what we do, we are CPS America. We have been the #1 market share in the three-phase string inverter category. We have a total of 26% of the market, and with Yaskawa with 9% of market share. We have already shipped over 4.1 gigawatt of inverter in USA. So CPS is a sub-branch of a larger corporation called Chin Power. And Chin Power, our mothership, has about $9 billion or more revenue per year. We are a publicly traded company, and we're also a very diverse energy company. In Asia, we are viewed as Eaton or ABB in that market sector. So the bigger corporation produce many more equipment related to power and energy sector other than renewables. So high power, high voltage transformers, medium voltage transformers, switchgears, GIS switchgears, many other equipment that's basically on and off the grid. And we are already in business for more than 30 years. In the US, we're obviously laser focused on three-phase string inverter, and we have been very successful so far. And of course, we are crossing the wonderful energy storage space. With that, I'm going to hand it over to the person who's in charge of the sector, Mr. Daniel Hill.
Great. Thanks a lot, Peter. And thanks, Dan, for the intro into the ESS market. Excuse me, I'm Daniel Hill, and I'm the CPS lead for energy storage. I'm going to take you through some information today. Certainly look forward to any questions you have later in the webinar. And of course, I'm more than happy to contact you at any time afterwards. So first off, I'm going to talk about getting started in commercial storage, talk about the challenges and questions about energy storage systems, then talk about our turnkey solution and how that relates to the challenges and some of your questions. And then we're going to talk about EMS systems. Matt Simo from Energy Toolbase is going to give a demo on their tool. And then we'll follow up with the CPS performance guarantee and warranty. Okay, so let's talk about some of the challenges. So first off, most of you probably haven't installed a system yet. I'm here to sort of help you guys understand that again now and in the future. We want to understand, what do we need in order to get a system installed, talk about functionality as well as size. So how much effort and cost will it take to get a system installed? What's entailed in permitting? What certifications do I need? What kind of electrical work do I need on site? What does commissioning look like? And then the same with final interconnection. Also going to talk a little bit about how to figure out what the right solution is for my client. Are they looking to lower electricity costs, like Dan mentioned about demand charge management? If so, for sharp peaks, maybe it's a smaller system where you can get great bang for the buck. If it's more of time of use or sometimes demand response, then it might be a larger system. Or is your client looking for microgrid backup? If so, how much power do they need and for how long do they need to back up their loads? We can also do both. If you have a system that wants to save costs when the grid is up, but they want backup for when the grid is down, we can do both. Obviously, financially, that can be a good way to sell a system, talk to them about their revenue savings, but then also sort of throw in the backup, like, okay, this is a relatively inexpensive backup system, given that you're going to be saving on your electricity bill through the ESS system. Okay. So now, I want to take you guys through the tools that we use to figure out what size and what type of EMS we want to use. So as I mentioned before, is it demand charge, time of use arbitrage, or is it backup and resiliency, or is it both? Obviously, we need some site data. If it's demand charge or time of use arbitrage, we need to understand what the usage data is, or at least have an estimate of what it's going to be. If it's backup and resiliency, then we need to understand the backup loads, inrush current, how much power do they need instantaneously, how long do they need the power, etc. So then we run our analysis. Again, Matt will take you through Energy Toolbase. Energy Toolbase is definitely the standard. It's the tool to use for solar plus storage analysis. Energy Toolbase also does the monitoring and control for a unit that's in the field. The other partner we work with on the software side is ELM FieldSite. They've got a lot of experience doing backup microgrid systems. Okay, and then we want to figure out what equipment. So how much power do we need? How many kilowatts? What size battery? How many kilowatt hours? And then what controls are we going to use? And then there's some conversation about disconnects and circuit breakers, especially when we're talking about a microgrid backup. Okay. So wanted to give you guys some visuals to look at here. This is our first generation system. We did a 30 kilowatts with 65 kilowatt hours. So that's a 2-hour battery. Or we could do it with a 60 and a 130. If you'll see on these units, the inverter and the wiring box are on the outside. The batteries are on the inside. With the current generation system, we brought everything inside. So the cabinet on the left is for controls and has the inverter, so that's the power side. And then the battery on the right is the battery side. Okay. So let's talk about some benefits of having a turnkey system. One of the most important benefits is that it really helps with the permitting. It helps to have all the certifications. The AHJ can see, okay, this is an engineered system. There's been a lot of thought that's been put into this to make this an all-in-one system. So they have a good feeling that it's all going to work together. The components are all pre-wired. It's factory tested. And it has the certifications. I'll talk a little bit more about which certifications we have. The other is the installation. There definitely are some systems out there, and certainly the past has been that pieces and parts get dumped at the job site, and then it's up to you guys to put those systems in, put them together, make sure that everything's working together, and that can take definitely days and sometimes weeks, sometimes longer depending on the system. Ours, basically, you're taking a forklift, putting it in place, wire it up like you would an inverter for a storage system, We need some communication to that system as well, but it's very fast. We will send a CPS person on site to do the commissioning. So we'll be there on site when the system arrives. We'll make sure that the system is functioning as it should be. Commissioning, because it's an all-in-one system, there's just a simple interface. We do the testing while we're out there on site. Okay, so a little bit more about the second generation. As I mentioned, it's two sort of main cabinets. Cabinet on the left is the inverter and controls enclosure, and then the battery enclosure on the right. Inside the inverters and controls enclosure is the CPS inverter. Size range goes from 62.5 kilowatts up to 375. And I'll talk to you a bit more about that. Energy management system is located here. And then the disconnects, circuit breakers, and AC connections are also located in this enclosure. For these systems, we're working with CATL. It's an LFP battery, 268 kilowatt hours. In this enclosure are, of course, the batteries and then the BMS system. So here are a couple of images of our system. So these are the inverters. You can see they've got 4 fans out in front there. And these are rack mounted, so they're very flexible. We can go as small as 62.5. For most systems, we're probably just going to start with 125. And then we stack them in blocks of 125 kilowatts. So we can do 125, 250, and 375. The battery enclosure, as I mentioned, is 268 kilowatt hours. If you do 2 of these, then it's 536, 3 is 804. The max size that we go to is 1,608 kilowatt hours. So you can stack up sort of systems. So you could, theoretically do 2 of these, but really sort of the max size for this, for what we call a system, would be 375. So we'd have 6 of these, and then we would have 6 of these enclosures. That would be roughly a 4-hour battery for 375 kilowatts and 1,608 kilowatt hours DC. The efficiency of the inverter is 97%. So for round trip, obviously you multiply that, and then there's some energy losses as you go through the batteries as well. So we end up in the high 80s for total round trip efficiency. We've got a nice wide operating temperature, got a temperature control system. So if it gets cold, we'll heat the system. If it gets hot, we'll cool it down. Modbus, simple RS485. And then just to show you, this box down here in the lower left of the battery cabinet, that's basically the battery management system. And then there's a handle there for the DC disconnect. Dimensions on these things are roughly 10 feet wide, about 7.5 feet tall, and about 4.5 feet deep. All depends on the AHJ. Most of these are going to be located outside. Most AHJs are, going to ask for roughly 4 feet on all sides around the system. Okay, so I mentioned earlier about certifications. So on the inverter side, we've got the 1741 SA, and then we also have the Rule 21 IEEE 2030.5. All of these come in a NEMA 3R and corrosion resistance rated enclosures. We do an extra salt spray so that these guys will handle sort of near ocean placements as well. For whatever reason, a lot of these are getting placed near, near the water. We have the UL 1973 certification for the battery cells, and then the 9540A for the battery cells, modules, as well as the entire rack. And that's certainly becoming increasingly important moving forward. Okay. So to talk again a little bit more about energy management systems, and again, Matt will give you a lot more detail about Energy Toolbase, but Energy Toolbase can provide now multiple revenue streams. It can do demand management as well as time of use simultaneously. It can also do self-consumption and demand response. So Dan talked about some applications in his introduction. We can meet those with Energy Toolbase in our system. On the resiliency side, ELM can manage the microgrid when the grid goes down. They can also manage generators as well as solar production. So if you need to dial the solar production down, curtail the solar inverters, we can do that. And again, depending how much power is needed, we can turn up or down the generator. So basically, the system ensures that the microgrid can meet the loads through the battery, the generator, and the solar production. Okay. So I'm going to hand it over to Matt, who's going to do an Energy Toolbase demo.
Hey, hello everybody. My name is Matt Simo. I am the Western Regional Manager here at Energy Toolbase. Thank you for everyone out there taking time to join us here today. And for those of you who are not familiar with Energy Toolbase and what we do, we are a software company that specializes in calculating the avoided cost analysis of solar PV and energy storage opportunities, as well as providing the software to actually operate energy storage in the field. Today, I'm going to be taking you all through a quick test case using CPS hardware and Energy Toolbase's Acumen intelligent control software. Just to start off, we're going to take a look right here inside this test case, and we're going to start off by looking at the utility rate. Now, in this example, we're going to be working with utility rate ALTOU, and that's with San Diego Gas and Electric out of California. And just taking a dive into the rate, the first thing I want to look at are the energy charges. The main thing that I want to point out on the energy charge side of things is the delta or spread of value between on-peak and super off-peak time of use energy. So at on-peak, we have our energy charge at just over 11 cents. We have off-peak, which is just over 10 cents, and super off-peak just over 9. So the reason why this is important is because when we go to model our energy storage, and we're going to go through the different storage systems and quantities, and most importantly, the controls, we want to make sure that we exploit the most valuable aspects of this rate and capture the most amount of savings we possibly can. So if we're going to look at doing a time arbitrage, if we charge our battery on super off-peak time at 9.3 cents, then turn around and discharge that battery at 11.8, the value to be gained is only just a few pennies. When you factor into the equation system losses, it really becomes very, very low gains, and for a lot of effort being put forth by the batteries. And even looking into the highest charges here in the summer month, just about 14 cents, and at the lowest, just over 9 cents. So at the most, right, we're looking at maybe 5 cents. So it's a very weak price signal on the energy side. But if we look at demand, that is a very, very different story. We can see here we have non-coincidental max demand at almost $26 per kilowatt. We have on-peak demand at over $20 per kilowatt. And we also have in the summer months that on-peak demand increases to north of $30. So the main value opportunity of this rate tariff will be the demand charges. So I wanted to point that out and keep that in mind when we loop in energy storage and we're choosing our controls. It's very important for everybody out there watching this video and in the field to be conscious of and understand the rate tariff that you're using. So let's take a dive into step 4 in our platform, solar PV. And I just want to simply point out that we do have a solar PV system modeled and included in the test case, 50 kilowatt system. And in that system, we're going to be looking to represent about an 84% offset of our utility or our customers' consumed energy. Now let's move on to energy storage. So just starting off on energy storage, okay? What we have here, we're modeling the CPS America 125 kilowatt 268 kWh system. So just over a 2-hour discharge. And a couple of things I want to point out here, and again, down here in performance info, we got the capacity and the power rating, but we also have the equivalent full battery cycle. So under these controls that we're going to run in this opportunity, we're cycling the battery 86 times, 86 full cycles per year. Discharging annually 21,653, and we have a blended savings of $82. So I want to quickly review some of these analytics and really mostly focus on the blended savings and why this is so important for all of you out there modeling these projects to understand this metric. So what this really is an all-in metric used to determine the value opportunity of energy storage. So the way we derive this number is we're going to take the calculated savings of energy storage by itself the very first year. We're going to divide that dollar amount savings number by our capacity. And that's going to give us $82 blended savings. So what this means is that for every kWh of capacity that battery holds, we're going to save our customer $82. So if we want to go ahead and reverse engineer this, we would say $82 blended savings times our capacity gives us $21,976 of savings from just storage the very first year. Now, oftentimes when you model these projects, you're not always going to get $82. This is a very, very excellent blended savings number. Sometimes you might get $30. It could be $50. We would consider anything north of $40 to be a pretty good opportunity. And to see $82 come in the mix is really good. So if you are modeling these projects and you don't see a really high blended savings, that doesn't mean it's a non-opportunity. Definitely get hold of us, get hold of Dan Hill at CPS. We'll make sure that everything's modeled correct. And with all the incentives out there subsidizing these costs, they usually do pencil out pretty nicely. So let's take a dive into CPS, into our integration. And let's go ahead and take a look at our design options. So here within the integration, okay, we're going to click down and we're going to see a multitude of different energy storage options. So we have the 125 268, we have a 125 kilowatt 536 kWh, so over a 4-hour discharge. We got models up in the 250, 375 kilowatt range and up as high as 500 kilowatts. And we have a 2-hour and a 4-hour option at a 0.5 megawatt power rating. So we pretty much have you covered from anything from like medium commercial to large industrial commercial opportunities. So after you select your system, right, you can choose however many of these designs that you want to see modeled. In this example, I just did one, but you can, do 2 of them, 4 of them, 10 of them, any quantity you really want. And then you would go ahead and choose the controls. So down here, right, we have a list of our Energy Toolbase Acumen Intelligent Energy Management System controls. So effectively, our control system is going to be implemented into the CPS hardware. Now, as part of the options that we have, okay, the first and foremost, we have self-consumption. This is the most simple option that we could have. This is simply saying that we're going to charge our batteries from solar PV generation. We're going to store that energy, and then we're going to discharge it when solar PV generally winds down for the day. And we're going to do so in order to offset our imported energy. Okay, so we charge from solar, discharge when the sun goes down. And there's no sort of, financial, motivation behind this. It's just a very, very simple strategy. The next one down is TRU arbitrage. So we have 2 different options here, one that has no charge restrictions and one that's PV charging only. So you would choose the no charge restrictions if you are either not going after the ITC, where charging from solar is a requirement, or if you just don't have solar installed on this opportunity, you might be batteries only. Then, of course, PV charging only. If we have PV and you're going after the ITC, we'll only be charging from solar generation. Then down here at the bottom, we have two more options. And this is our demand charge management and TOU arbitrage. So effectively, these controls here are very, very intelligent, forward-thinking controls. They're intelligent enough that they learn the habits of what's going on, right on site, from what's being pulled in from the grid, what's generated from solar, and actually changes within the rate tariff. And that's part of using our controls. When we update our rate tariffs, these intelligent controls take into account those changes and update the intelligence behind the dispatch and the control logic. So we also have this in no charge restrictions and charge from PV only. So in this example, I'm going to be using the charge from PV only and working with the demand charge management and TOU arbitrage. And the next thing I want to talk about is, how do you guys know as developers out there, what is the best system to use? What's the most cost-effective system? Or how many of said systems is most appropriate? So we have this button here in the right-hand corner, ETB Optimizer. And this is a simulation engine. What it does is when you click on this button, it's going to look backwards at the energy profile or data that we have loaded. It's going to look at the specific rate tariffs that we're using and the value opportunities within it. We're going to look at the solar PV, if it's present or not, and if it is present, what effect does it have on the project? And then finally, it's going to look at this system and the controls. And the reason why this is important is because there's a lot of aspects that go into the energy storage dispatch. And Energy Toolbase does a fantastic job looking at all these different aspects and putting together a very solid and accurate financial analysis. And that's really what we're known for in the field. And why we work so good with CPS, because they're such a good hardware company. We have great analytics and we have very, very intelligent controls. So looking at the optimizer, when that runs, we're going to get 6 different charts here, okay? So there's 4 right here and 2 more at the bottom. So the first one we have here is blended savings. And you can see here right at the start, there's that one CPS 125 kilowatt 268 model that we have installed already. And there's our blended savings, $82. The next one down, if we were to stack those, okay, and have 2 of those systems installed, our blended savings would drop. And as you increase your battery sizes, in terms of stacking these, our blended savings keeps going down. So why is this happening? Okay. So to start off, we have our total electric bill savings. And with one of these systems, we can see we're saving about $22,000. But if we double that system, our savings only goes up to about $24,000. So we have an increment of $2,000 of savings when we doubled our system. So following the logic behind our blended savings calculation, okay, total savings divided by our capacity, right? Without a big increase in savings and doubling the capacity, we have a drop in blended savings. So it doesn't, again, mean it's not a valuable system by any means. It just doesn't have as much value per kWh as the first system. Moving down, we have a few other charts. And really, the most important one that I want to talk about here is annual exported energy. And the reason why this is really important, and it really depends on the market that you're working in. We have customers and companies that we work with all over the world and a lot of different markets. So in certain markets, you need to be very conscious of what metering configuration you're working with. For an example, here out in Hawaii, a very common interconnection agreement is called CSS, or customer self-supply. Under that interconnection agreement, you're not allowed to export any energy to the grid. And if you do happen to do it, you get 0 value for all that exported energy. So in this example, this optimization engine tells us, hey, if we add more batteries, we can show what the decrease would be in our exported energy and therefore create a more valuable project. So this tells us either we need to increase our capacity of the battery, or we need to reduce our solar PV size and therefore reduce our exports. So all in, right, this is a really valuable metric and tool in Energy Toolbase, and it just really helps our developers, everyone out there listening, just create the most cost-effective proposal for your clients. So after we get our energy storage dialed in, okay, next thing we want to look at is the transaction. So on the transaction side of things, we're going to be looking at the way in which our customer might consider paying for this project. And what I have loaded in here is just very simple, is a cash purchase, but it's going to be our ETB Acumen controls. And the reason why this is important is when you're going to use CPS hardware through our software integration, okay, we do a great job of forecasting what all the costs are going to be to your customer. And that's very important. Accuracy in this field equals longevity. And if you are proposing projects that, don't kind of come to fruition of what you say they're going to do, a lot of companies aren't going to last long. So it's very important to make sure that you are encompassing all the financial metrics and pushing out an accurate proposal. So with this transaction, what we actually do, depending on the energy storage system that you use, we're going to forecast what the renewal cost is of the new license to have our Energy Toolbase Acumen controls. So an example is going to be here in the document. So I'm going to show you kind of forward right down to the cash flow, and I'm going to show you exactly what I mean. So here's our cash flow for this project we just kind of put together. And the main thing I want to take a look at right now to start is this IEMS license renewal. So when you first purchase the CPS hardware, it comes with our controls, and as part of the cost, you get 10 years worth of those controls. Okay, so the licensing agreement for 10 years. Then we show you automatically, right, based on whatever system you design, what the anticipated cost is going to be to renew those controls for another 10 years. So here we can see that at year 11, we have a cost of $29,000, and that's good for another 10 years. Now, the cool thing about this too is that, as software advances and things kind of end up getting cheaper over the years, this $29,000 is most likely going to be less expensive. So what we actually do here is present a little bit more of a conservative approach to what that cost will be. But it dynamically tells you that, and again, creates that transparency to your customer. Then, of course, here we have our SCHIP incentive. So if you're modeling projects in California, SCHIP is a very valuable incentive. Then we have our electric bill savings, right? We have our state and federal incentives. And then we have our total cash flows. So if we invested $305,000 with PV plus storage, we're going to make our money back in this opportunity in 3.6 years.
Sorry, I'm having.
So that being said, at year 4, we're going to be making $15,000. And at the end of just 20 years, we're going to be making almost $500,000, $600,000. So just goes to show that with the right rate tariff in certain markets, man, energy storage is super valuable. And from start to finish, we can help you model these opportunities. So if you have any questions, please let us know. And we're happy to look at anything that comes across your plate. So that's it for me. I'm going to pass it back. Thank you.
Great, Matt. Thanks for that.
Yeah, thank you, Dan.
So as a wrap up, wanted to talk about warranty and performance guarantee. So we do a 10-year warranty for our system. For individual projects, we can sort of look at the battery usage and get an idea for how long that battery is going to last. For the most cases with an LFP battery, we'll probably have 15 years at a minimum. And then if you're using it sort of only for microgrid or sort of not exercising it fully on a daily basis, we expect that it will last longer. And then we and Energy Toolbase together also have a performance guarantee. Basically, we're guaranteeing the revenue stream. Matt, did you have anything to add to that on the performance guarantee?
Yeah, thanks, Dan. So when looking at the performance guarantee, as you're developing projects, within ETB, and we're definitely looking at, CPS and their fantastic hardware and support team. And then we look to do our financial analysis. We pretty much go case by case and provide a performance guarantee on what our controls will provide your customer. So yeah, just letting you guys out there know, that's something we provide. And please don't hesitate to ask if you have any questions about that.
Great. Thanks a lot. So I'm going to hand it back to Peter, who is very knowledgeable about CPS's local service and engineering support.
Thank you, Daniel. Yeah, so I'm very proud to present our awesome local in the USA service engineering support. On the left-hand side, the picture you're seeing is our leader for our service department, James Oswald, whom most of our customers are very familiar with. We take the pride of service engineering very personally, and we have techs right now over almost 20 headcounts of technicians. That's all over the country. Their location will be in the next slide. But we do provide 24/7 remote troubleshooting, and we also go to the site in person with very highly experienced field support. So our reputation is out there, and our service that we provide for our existing asset, which is mostly solar PV inverters, really helped us to be successful in this business, and I'm sure it will help us to be successful in the energy storage sector, which is essential for this business. Sorry. Yeah, so we have a 3-to-1 service to sales staff ratio. It is very different from our competitor. We invest tremendous amount of money to build a world-class service team that we think is essential to help our business to be successful. And we also make sure all of our service personnel, including the people who answers the phone calls, answer customers' questions, are all located in the U.S. They are mostly located in Texas. But as you can see, our service technicians are over the East Coast and West Coast and of course, middle, where most of our customers are. So that covers almost all the U.S. territories. We also want to take this opportunity to give our loyal customer a sneak peek of what CPS is cooking in 2021. We're proudly presenting our 1500 volt DC, 800 volt AC, 275 kVA inverters that is going to be shipping in Q2 2021. It is designed for large utility scale projects, 225 kVA to 50 kilowatt AC at 45 degrees C. DC-AC ratio up to 1.86 is going to come with IV curve function, with POC functions available for those who want to use POC, with 36 DC input to ensure you have enough inputs for the high DC-AC ratio scenario. So this will be our next generation utility scale inverter, string inverter, almost small central, large string inverter. Next product we're introducing very shortly to the market is in Q1 2021. It is a upgrade or a variation of our 1500 volt DC, 480 volt AC output string inverter, also designed for ground mount projects, mostly in community solar, where the interconnection voltage is 480 volt on the low side of the transformer. There is a big market for existing utility transformer that has 480 volt instead of the 600 volt or 800 volt. It is 111 kVA, 100 kilowatt AC at 45 degrees C. Again, the DC ratio up to 1.87, same with all of our other 1500 volt line. Remote IV curve function, 20 string inputs, again, POC function is available, and it's a smart inverter function compliant, Route 21, California. Yeah, I think with that, we're gonna go into the Q&A section.
That's absolutely right. Thank you so much, Peter, Daniel, Matt. My key takeaway is that even if you're making storage simple is not simple. Clearly, there's a lot going on behind the scenes here, and we appreciate taking a look behind the curtain a little bit. We have a lot of great questions that have come in. I have a bunch here. Through as you can, please keep them coming. Answer as many as you can. And be able to send any unanswered questions over to the CPS team as well. So let's dive in. We have a couple of questions about battery chemistry. This is an area that I'm very interested in myself. You mentioned that you're using LFP batteries, I believe, so some of the questions here are regarding that, which I believe we covered. But can you talk a little bit about why you made that decision? What were the drivers and how you decided what battery chemistry or technology to use? And then is there anything on the horizon or other battery chemistries that you have your eyes on as well?
Yeah, so thanks, Dan. Great question. So people are probably aware that right now there's a challenge in getting batteries. Southern California is installing a huge amount of batteries. They're being used for automobiles as well. So we'll see how this works sort of in the longer run. But we were using NMC, LG Chem, on our smaller systems. And availability with those batteries is increasingly difficult. We have a strong partnership with our Asian parent company, Chimp Power, with CATL. They've installed, I think, about 30 megawatts of batteries in Asia. Lithium phosphate does have a longer life. It is a little bit more amenable to higher and lower temperatures, to temperature swings. They are heavier and they do take up more space, so they're probably not quite as attractive for EVs. So that's giving us a little bit of an avenue in terms of being able to use them. You know, moving forward, we've all sort of watched the different chemistries and promises that are coming up, and I'm sure that battery efficiency is going to get better, pricing is going to go down, but at this point we're pretty excited about this using this LFP battery here in the U.S. with CATL.
Fantastic. I'll do a little plug for my colleague Mitali Gupta, who just did some great research on this at Wood Mackenzie on this emerging trend, and you're definitely ahead of this as we actually anticipate the LFP market is going to be the plurality of lithium-ion chemistry within the decade. So very, very much an existing and ongoing trend. A couple of other more technical specification questions. We have one question here, which is wondering about the offerings for other systems, 30 kilowatt, 65 kilowatt hour, some of those other systems, and a question on the timeline of the 500 kilowatt system being available. So can you tell us a little bit more? Maybe we could go back to the slides as well if you'd like to, just about what is going to be available, what timeline is that?
Yeah, so that's great. So first off, on the 30-60 kilowatt, you know, I mentioned that we did sell through those systems. We really don't have any plans in the short term to bring those back. I will say that we've had a lot of interest in bringing those back. So, you know, certainly never say never. It's not something we will do probably in the short term, but in the longer term, I think we will have an offering for a smaller system. Longer term being probably later next year. On the 125 system, we've seen a lot of interest. As I mentioned, it's a challenge right now to get batteries. So we're probably sold out through first and second quarter, probably looking at Q3 now, and then, you know, as interest in battery systems grows, you know, we might be pushing that back. On the other hand, I know they're working on producing more of these batteries. You know, it'll be interesting to see sort of, you know, how the battery market does, if it can sort of meet this demand and get the lead times down a little bit.
Yeah, there's a dramatic scale up in manufacturing that we're tracking going on as well, but it feels like across the industry, everybody's dance card for 2021 is starting to fill up. Good to know. A follow-up question on that one a little bit. Are there limits on stacking? In particular, this person's asking about the 375 kilowatt systems.
So I think, if I understand that question, so yeah, you can do a 375, as I mentioned, with as much as 1608, and we sort of consider that a system. And then you can parallel those systems. So I think of them as sort of big big solar inverters, basically. You just
Mm.
put them next to each other, and that you would need to, you can bring them into a common bus if you want, but you could stack as many of those, as you wanted, depending how depending on the site. They would all be controlled by one system. So if it's Energy Toolbase would be communicating with all systems simultaneously and controlling those.
Got it. Great. All right, we've got some good questions here on some more technical aspects, but one in particular on safety, which I think is a real a crux of an issue in the C&I market in particular. The question here refers back to slide 16. Do the racks require any additional fire suppression equipment at the installation site? Could you talk a little bit about what sort of safety and fire suppression pieces are needed here?
Yeah, so that's a great question. So, when we got into this a couple of years ago, sort of our standard was to include fire suppression with all systems. As we've moved through the certification process, UL and other certifiers have basically said, you might have one AHJ that is demanding, one solution, and you might have another AHJ that's demanding a very different solution. So at this point, we have a few different options. We set up the system so they're ready to add whichever option, but we're not shipping with any of those. There's also a difference if you're outdoors, for the most part, because we do have the 9540A and the batteries. For the most part, we don't need fire suppression. If it's an indoor system, sometimes the rules change, and then obviously it depends where in the country. New York is sort of leading the charge on 9540A, whereas other parts of the country have different ideas in terms of how they want to deal with fire suppression.
Yeah, absolutely. Is it moving towards any sort of synthesized approach or anything strategically that you're doing to meet that sort of patchwork that's existing right now?
Yeah, I mean, the main thing is that we do have the 9540A.
Yep.
And that is that's the standard now, and that standard is changing. But for now, it's they do testing to make sure that there isn't going to be a fire that's going to spread on site, or there aren't going to be gases that are going to be released if a cell or a module starts heating up.
Fantastic. Another thing that relates to safety a little bit, are CPS technicians required to install and service CPS inverter and storage products?
Yeah, good question. So for the first system, or the first couple of systems, as I mentioned, we're very happy to hold your hand. We're actually not installing the system. We're commissioning the system. So you guys in the field will be wiring them, bring the wires to the unit, conductors, as well as the communication to the unit, and then we will do the commissioning with Energy Toolbase at the job site. Now, once you've done a few, you may or may not need us out there, but certainly here for the next 6 months, we plan on being at the job site for all systems commissioned.
Great. Another question here is on a specific application, which I find fascinating. I'd be curious your approach on this. It's actually part 2 to an earlier question. Great way to get your questions in early so that we see them. Have you deployed for electric fleets to provide time of use arbitrage? So something involving how fleets are charging or discharging, I guess, which ties in, of course, to this demand management application. Any sort of pilots with that, or is it that you see as promising?
Yeah, so I'll say that I've probably had more conversations about that than traction, although we do, we are looking at a couple of systems that will probably be going in the next 6 months. As you know, fleets take up a lot of energy. There's an application for demand management because you get such big peaks, and there is a time of use application, but of course it comes down to utility pricing. I would say more promising in the short term is going to be demand charge management, given the spikes that a car charger has.
Great, great. I see a question here that I think is really important to address, just because we have both the Energy Toolbase and CPS folks on the call. The question is Acumen ETB's controller algorithm or CPS's? So maybe you could just sort of clarify a little bit about that and how both these organizations sort of are involved in the process.
So I'm going to defer over to Matt on that one.
Yeah, thanks, Dan. Yeah, absolutely. So yeah, just to be clear, so ETB, Acumen Controls, they are Energy Toolbase's control. So brief kind of history on that is about a year ago, Energy Toolbase underwent, collaboration with a large company called Payson Systems. And because of that, merger, we then gained access and the ability to create the software driving the battery behaviors. So with the CPS integration and then Energy Toolbase, our controls, Energy Toolbase's Acumen controls, are powering that behavior in the field. So that's something that we are really, really excited about, just kind of moving into that market. And just more and more opportunities moving forward. But the main thing is that because you're using our controls, that's one of the reasons why we will be looking to guarantee the savings of what we project with CPS's systems, because they're powered by our controls.
Got it. That's a great clarification. Thank you. A couple of questions here that I'm seeing trickle in on the warranty, whether it covers shipping, parts, and labor. Obviously, these warranties are really important for people trying to pencil out a storage solution. Can you mention a little bit, or just reiterate what that warranty includes and sort of where you see, or any sort of trends that you see in how warranties are evolving in the storage space? Always something I'm curious about.
Yeah. So the warranty can vary a little bit on site and how the battery is used. I do believe that LFP batteries, as I mentioned, it appears that they have a longer life, and we are going to be able to offer a longer warranty with LFP than we are with NMC. So what's included? So the entire system has a warranty. We're basically bringing the battery warranty with the system as well as the inverter warranty. So those are really the two main pieces that, that could have some challenges. I would say also that, if you want to follow up with me, I can sort of go through some more specifics on that. There are some sort of replaceable parts. There's not much there. It's pretty straightforward.
Yeah, feel free to follow up with questions in the platform here, or directly to the emails you see on the screen as well. That'll go directly to the CPS and ETB team. Another question sort of related to the warranty. At the end of this term, the contract term, what happens if you don't renew that contract, or what are the steps following those 10 years?
So that's a great question. Thanks, Dan. So looking at the CPS hardware, so looking at the battery lifespan, right, roughly, 10, 11 years, is provided under warranty. So if you don't renew that license, then the batteries would effectively not be active. So if you want to use the batteries again or renew the battery cells on site, you definitely want to make sure that you repurchase the next round of license agreement.
Got it. Great. All right, so we're coming up at the end of the hour. We've got some other questions that have been trickling in. We'll be following up with those. For the CPS and ETB teams, I'd love to sort of put you on the spot. And I used to call this a water cooler moment, but with a lot of people working from home or quarantined, maybe it's now a kitchen sink moment, or when you're on a Teams call with your colleagues moment, or a Zoom call. As people are leaving and they're taking a key takeaway here, what's the quick 30-second soundbite of the key thing that they should take away from this conversation about how C&I projects for energy storage are getting simpler? So a cooler soundbite, please feel free to jump in.
Yeah, so this is Daniel. I mean, I think, this is an evolving space. We definitely see direct applications right now. So I think the main thing to do is really, interact with Energy Toolbase, with Matt or with me, and we can help you figure out, everything you need to know to understand if it's going to sort of work for your specific project.
Yeah, and just kind of piggybacking on that, there's a lot of things to consider, kind of like you stated earlier, and just one of the benefits of, working with people at CPS and Energy Toolbase is that we help guide you every step of the way. And we really just make sure that we go over all the details and key aspects of the project and just make sure everything's looking good. And then from there, just help get you the most value we possibly can out of the opportunity. So when you work with us and CPS, you just get a ton of support. So we always encourage anybody using the integration and CPS and ETB, just please reach out and we're happy to help.
Great. All right, we're at the end of our time. This has been a fantastic conversation. I'll use an opportunity to plug our Energy Storage Summit starting Monday. The signups are still available for that if you want to keep the conversation going. You can actually use a code that they made for me, DFF20, and you can get, I believe, a 20% discount on that as well. So hopefully we'll see some of you there at that event. With that, I would really just like to thank the CPS and ETB teams for giving us this insight today, and thank everybody for joining us and for your questions. Thanks so much, everybody.
Thank you, guys.
Thanks, everybody.